Conic sections are called conic sections because we get them from taking a cone and slicing the cone. So cone, conic. So a circle comes from slicing right across, parallel. An ellipse comes from slicing at an angle. A parabola comes from slicing off an edge. And a hyperbola is from having two cones that are end to end and slicing through both of them. So anyway, sound familiar? Okay, so this is our form. Really, this is the form we learned for an ellipse. That doesn't mean we have to only do ellipses. We could use the same idea for if it were a hyperbola or a circle. It's just that the Pythagorean identity, cosine squared plus sine squared, is going to work best with just melding them all into this model. All right, so we've got this, and we're going to need to complete the square to put this in standard form for a conic section. I'm just going to say put in form x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay. So here we go. We have x squared plus 2x. I'm going to leave some space. And then I have y squared minus 4y, and I'm going to leave some space there. And that equals 4. So to complete the square, we're going to do half of 2, which is 1, and 1 squared is 1. So we add 1 there, but we also add it here. And then for this one, we're going to take negative 2, because it's half of negative 4 is negative 2, and we square it, so we're adding 4. If we add 4 to one side, we have to add it to the other side. So that gives us x plus 1 squared plus y minus 2 squared. I've just factored these, equals 9. This is a circle. But in order for us to apply the Pythagorean identity to it, normally for a circle we would have left the 9 over here and know that the radius is 3 for our circle. But we're not going to do that. We're going to divide everything by 9. So divide by 9, divide by 9, divide by 9. It is a circle because the coefficients on x and y are both the same. So it is a circle. Its center is at -1, +2 with a radius of 3. However, I want it in this form so that it equals 1 so I can use Pythagorean identity. So we're going to do x plus 1 squared over 9. I don't know why I have that extra parenthesis there. And y minus 2 squared. You know what? I'm going to rewrite this as 3 squared. That will actually make it make more sense. Yeah, maybe that's why I did the whole big parenthesis. Over 3. We can just put the squared on the outside of that. And then this would be 3, because 9 is 3 times 3, right? Does that make sense? Anyone lost in what I did just now? I'm trying to make it look like this. Maybe I didn't need to actually separate out the squares like that. But what I'm trying to accomplish here is replace this whole thing with sine. Oh, actually, that should be cosine because it's x, right? Replace that whole thing with cosine. And we're going to throw a t in there. And replace this whole thing with sine. It's always a sine. Okay, so what does this tell us about cosine if cosine squared is x plus 1 over 3 squared? So using that information, the cosine of t equals x plus 1 over 3, which means 3 cosine t equals x plus 1, which means x equals -1 plus cosine t, or you could put the -1 after it. It doesn't really matter. Then likewise, we would have I certainly did. Thank you. Okay, forgot the 3. Sorry about that. So sine of t is going to equal y minus 2 over 3, which means 3 sine t equals y minus 2, which means y equals 2 plus 3 sine t. So we have our set of equations from x equals -1 plus 3 cosine t and y equals 2 plus 3 sine t. Okay, did it give us a parameter, a restriction? Find a parameterization. Oh yeah, 0 to 2 pi, because we just want to go around the circle once, right? Which means we probably shouldn't include 2 pi. We should start at circle and end up just, yeah. Is it? It doesn't have to be. Oh, it is though. In my notes, in this thing I put right here, it's included. Well, that's weird. I don't think it's necessary, right? I don't know. Is that a mistake in the textbook that we need to fix as we're revising it? Puzzling. I'm puzzling. Do you need me to draw this, or are we good? It's a circle. Center -1, 2, radius 3, blah, blah. And the orientation goes counterclockwise around the circle, just like we would do with the unit circle.